It's work these days. Okay, so today, 3/8. My daughter turns 30 today. Isn't that depressing? 3, 9. Actually, she was kind of born yesterday because she was born in Japan. My daughter's born in Japan, which is one day ahead of us. Isn't that crazy? Yeah. Okay, so today's objective is really going to be simplifying roots and fractional, what we call it rational. The word rational means fraction. Rational exponents. So when you say the word rational, rational is just a fancy word for fraction, okay? All right, so we talked about a little bit of this in the warm-up. You know, we wrote down our special square roots, and so in our warm-up we looked at all of our perfect squares. Antonio said, yeah, Mr. Davies, those are perfect squares. He was right, because they all have square roots, right? Those are the numbers we want to key into, okay? So example 1, if I want to simplify this, I'm going to look at this as two different problems, right? Square root of 27 and the square root of x to the 8th, okay? Square root of 27 is really a pretty ugly number. If I go square root of 27, I get this bad looking decimal irrational number. So what I'd rather do is find a way to reduce it. So we're looking for multiples of 27. We'd really like to use one of these numbers, so hopefully, you know, 9 and 3, you guys agree? 27 would be 9 and 3. So I'm looking for a pair of multiples where one of them has a perfect square. Okay, what times what makes 27? How about the square root of 9 times the square root of 3? Okay. I know that x to the 4th times x to the 4th makes x to the 8th. So what I want to do is take the square root of x to the 8th, which is just going to be x to the 4th power, okay? We talked about it in the warm-up that we just take half our exponent. And I did. I took half the exponent, I get x to the 4th. Well, I'm almost done on this problem because I can simplify a little bit further because I know what the square root of 9 is. That's just 3, right? So I'm going to get a 3 from that square root of 9. I have an x to the 4th, just plain old x to the 4th. And then I got a square root of 3. And I'm going to leave the square root of 3 as square root of 3 because square root of 3, again, is a really ugly number. I can either take that answer, square root of 3, or this ugly answer. I don't want that ugly answer. That's just ugly. So I'm going to keep the square root of 3. All right. Let's look at number 2. Okay, number 2 has a whole number in it, the 3. I like that. I don't have to do anything with it, but I can't forget it. I like the 3. It's a nice number. It's a whole number. I'm just going to write it down. I don't want to lose it, but I don't have to do anything with it, okay? Just leave it alone, okay? But the 18 is inside the square root, so I'm looking for two numbers that make 18, not 6 and 3. Not 6 and 3, but how about 9 and 2? Because 9 is a perfect square root, so square root of 9, square root of 2. And then the x to the 7th, we'll look at that as two parts, but what I want to do is take half of it, but I can't take half of a 7 without getting a fraction. So we're going to rewrite this as square root of x to the 6th times the square root of x to the 1. So I take 1 away. So if I take 1 away from an odd exponent, take 1 away, then I get an even number, okay? So if I just take 1 away, I get x to the 6, x to the 1, and then I can take half of that, right? So let's go through. I get square root of 9. That's 3. I'm going to take the half of that, square root of x to the 6 makes an x to the 3rd. And the square root of 2, I'm going to leave as square root of 2 because I don't really want a square root of 2. It's a really ugly number, right? I don't want that. So I'm going to leave it as square root of 2. And I may as well leave the x with it because there's my square root of 2, and there's my x. And then finally, 3 times 3 is 9. All right, so simplify. What happened is we took this problem here, and it's just much nicer. We got as much out of the square root. That's our goal. Our goal is to get as many numbers out of the square root as we can, okay? Because then we can do something with it, okay? All right, slide it up, okay? Number 3, well, let's multiply. It says times. We can multiply, square root times square root. We can multiply. So 15 times 5, I think, is 75. Okay. And 75, I think I can do something with 75 to reduce it. If I look at my square root numbers, I think 25 goes into 75, right? So as far as multiple 75, let's change this to square root of 25 times square root of 3, okay? And then what's square root of 25? 5, right? Square root of 3. And leave the square root of 3 as it is, because otherwise it's just an ugly, ugly number, right? I think square root of 3, yeah, you don't want square root of 3. Okay? Okay, number 2, it's also multiply, but multiply whole numbers with whole numbers, square roots with square roots, okay? Whole numbers with whole numbers, right? Square roots with square roots, okay? So 2 times 4, that's easy, that's 8. And then square root of 3 times square root of 6 is square root of 18, okay? Now the 8, leave the 8 alone. It's a whole number. Leave it alone, leave the 8 alone. But what about the 18? It's a square root. So the 18, we might be able to do something with the 18 if we find one of these numbers that multiply to make 18. Well, how about that one, right? That goes into 18, and that's a perfect square. Square root of 9, square root of 2. You know the square root of 9 is 3. So we have 8 times 3, square root of 2. Now 8 times 3 is 24, square root of 2. And leave the square root of 2 as square root of 2, because otherwise it's just an ugly number, right? Okay. All right, number 5. Am I going too fast? Okay. So here's, it's just like x's and y's. You cannot add them unless they're the same. You cannot. They're not the same. So you can't add them, so you're done, right? Move on to the next problem, right? But no, wait a minute. You might be able to reduce that 8 and that 18, and maybe after I reduce them, they might be the same. So let's see if we can do some work, and maybe they become the same. And if not, then we're done. But so let's see on 5. 3 is a whole number, so I like the 3, but I'm going to leave the 3 as a whole number. But the 8, it's the square root of 8. I like the square root of 4 times the square root of 2, right? Because then what I can do with the square root of 4 is take the square root of 4 and make that a 2. So I took the square root of 4 and I got a 2. And then I'll go 3 times 2 is 6. Square root of 2, okay? So this number got changed to that. They have the same value, but it's just a better number. Now what about over here? Let's see what happens here. So 5 square root of 18. Well, the 5 is a whole number. I like that. I like the 5. It's a nice number, so I'm going to leave it alone. But the 18, I'm going to reduce 18 into, oh, we just did it up here, so I know how to do it, right? Square root of 9, square root of 2, right? And I know the square root of 9 is 3. And I know, wait a minute, 5 times 3 is 15. Right now, oh, this is nice, because I said you cannot add them unless they're the same, but they are the same, aren't they? So I'm going to say, okay, I got 6 square roots of 2 plus 15 more square roots of 2. So if I add them, I'd have 21 square roots of 2, right? How many square roots of 2? Now I can add them. 21 square roots of 2. Okay. All right, let's take a look at example 6. How am I doing? We did do this last year, but that's great if you've forgotten. This parentheses is not very big, but that's because it came off the computer type. But it is really a distributive property. It's like really this times this, this times this. It's just hard to see because I didn't make the parentheses very big. But it is. So I'm going to multiply twice. I'm going to multiply here, and then I'm going to multiply here. Okay, so first let's do the first multiplication. So we're going to go 3 square roots of 3 times 2 square roots of 6. Let's see, that's going to be a 6 square roots of 18 plus, let's see, 3 squared root of 3 times 5 squared root of 3 is going to give me 15 square root of 9. Okay? Well, I see some things I can do. I really do. There's more. The 6 is a whole number. I'm going to leave it alone. But the square root of 18, I'm going to rewrite as a 9 square root of 9 times square root of 2. Because that will reduce my square root of 18. Not 6 and 3. Over here, hey, this is easy. It's already done for me. What's the square root of 9? Boom, just plain old 3. That's a nice number. Square root of 9 is just 3. Plain old whole number 3. All right, I'm getting there. So now I'm going to go 6, and the square root of 9 is 3, square root of 2. And I'm just going to leave the square root of 2 as square root of 2 because square root of 2 is a really ugly number, right? There it is. Leave it. And then this is just 15 times, those are both whole numbers, so 15 times 3 is 45. Okay, just regular whole numbers, right? Okay, I'm getting there. Whole numbers, I can put them together. 6 times 3 is 18. Square root of 2 plus 45. Now, what I said over here was that you cannot add them unless they're the same, right? You cannot add them unless they're the same, so I can't. I can't add these. I'm done. That's it. That's my answer. Cannot add them unless they're the same, okay? If they're the same, I'd add them, but they're not. Okay, number 7 is a FOIL problem. And of course the parentheses aren't very big, but you know they are. They're supposed to be right here, here, and here, and here, right? So it's a FOIL problem. So we're going to go this times this, this times this, this times this, this times this, right? Okay, let's do it. 2 square root of 3 times 5 square root of 3 is going to be a 10 square root of 9. Now watch this carefully. Whole numbers with whole numbers. 2 square root of 3 times 5. 2 times the 5 is 10. Minus 10 because of the negative. And then square root of 3. So you multiply the whole numbers. And the same thing here. You multiply the whole numbers. 1 times 5 is 5. Square root of 3. And then finally, 1 times negative 5 is negative 5. Okay? So there's more I can do. There's more, always more I can do, right? Square root of 9 out. The square root of 9 is, what's square root of 9? 3, right? 10 times 3. And these two are the same. These two are the same, so we can actually add them. We'll subtract them, really, but we can put these together because they're the same, right? We can get negative 5 square root of 3. Okay? I'm getting there. Well, those are whole numbers, right? That's 30. So all I do is just make that 30. And now finally, whole number with whole number. 30 minus 5 is going to be a 25 minus 5 square root of 3. Now, can I do more? No, because if they're not the same, I can't add or subtract them. Can't do any more. They're not the same, so I'm done. Okay? All right, turn the page. It's kind of, okay, now, here comes the easy stuff, okay? I'm going to write it down again, okay? I'll write it down. We talked about how if we had some number to a fraction exponent, to the p over q, right? Any number to a fractional exponent. You can rewrite it as a root. That's my root, and that's my power, okay? So you can rewrite it. You can go either way. You can go from this way to this way or vice versa, okay? So, example 8. First, let's rewrite it, okay? So I'm going to rewrite it from this form to this form. I'm going to go from here to here. Well, the 5 is my root. So I'm going to go 5 goes there. So my 5 goes there. And then 32 to the 2 power goes there. Okay? So if we rewrite it, that is the answer. Now, if we wanted to solve this, okay, if we want to solve this, right? I think you noticed. what times what times what times what times what makes 32. Ready? What times what times what times what times what makes 32. What times what times what times what times what makes 32. Ready? 2 times 2. 2 times 2. Come on, 2 times 2. Times 2. 8 times 2 times 2. So I know that 2 to the 5th power is 32. So the 5th root of 32 is 2. It's got to be. Now, you can always use a calculator if you don't know these, but that is going to be 2 to the 2nd power, which is 4. Again, I think my calculator will do these, which is kind of cool because if I go parentheses 32 to the power of 2/5, hey, I get 4. What do you know? But I can use my brain because my brain's smarter than that. Okay, now, example 9. Let's rewrite. So first of all, this one needs to go into that form. Okay, let's rewrite into that form, okay? So my number is 27. And then I'm going to go to the 2/3 power. Now this answer is 9. How do I know it's 9? Well, cube root of 27 is 3. 3 squared is 9. But if you don't know that, well, let's see what we got. We can take parentheses. We can take 27 to the power of 2/3. And I get an answer of 9. Okay? It is 9. All right, last 2 problems. I'm done, okay? I promise. Been a lot of things today, huh? Solve the equation. Okay, so solve it. Well, let's see. We can solve this. What's the first step we should do? Solve for x. What's the first step we should do? What do you think? Hello? What's the first step we should do on number 10? Come on, you guys. Wake up. What's the first thing I should do? Almost. Let's divide by 2 first. Okay, let's divide by 2 first. But we're going to do that. We are going to do that. Divide by 2, divide by 2. X cubed equals 30. Okay. And then what we're going to do is cube root it. Does that make sense? We're going to cube root it to get rid of the cube. So we cube root both sides because that'll cancel it. Now, how do you do the cube root of 30? Well, my fancy calculus will actually do this. We can go, I have a little math button in here that has a cube root of 30, right? I get about 3.1. Or you can do 30 to the 1/3 power. That was the same thing, right? 30 to the 1/3 power, because we learned about that. Okay. Last but not least. Well, the 5's inside, so I can't get rid of the 5 yet, because the 5's inside, so I can't get rid of 5, but I can square root this, right? Okay, square root, square root. I'm going to get an x minus 5 equals the square root of 50, okay? Oh, wait a minute, square root of 50, I can probably break up into, I can do something with this. I can do something with this. Square root of 25, square root of 2. Right? Instead of an ugly decimal, I don't really want an ugly decimal like that. I'd rather have a nicer answer. So I broke up 50. Square root both sides. Square root, right? Square root of 50, okay? And 25 and 2. So I get an x minus 5 equals square root of 25 is 5, right? Oh, and there's 2 answers, plus or minus. And the last thing we do is just go plus 5, plus 5, plus 5, plus 5. Now wait a minute. Wait a minute. I can't add these because they are different. So it's a weird looking answer, but that is your answer. You can't add these because they're different. I'd like to, but that's square root of 2 and that's not. Okay, that's what I have for today, okay? So a couple of things before I completely sign off.